Types of system. First type we are taking isolated system. A system that cannot exchange mass or matter and or energy from the surrounding is called isolated system. That is, in isolated system is cut off from the surrounding. There is no exchange of matter, there is no exchange of energy with the surroundings. Example is thermos flask. If you keep ice, milk, or any other liquid in a thermos flask, you know it's an isolated system. Why it's an isolated system? Because no matter can go inside and no matter can come out. Similarly, energy cannot go inside and energy cannot come outside. So that's why it is called isolated system. But don't forget, in thermos flask also, if you keep hot coffee, it will not remain hot forever. It has some life, it may remain hot for few hours, not after that, because perfect thermally isolated is rare. It's not possible that we get the isolated system which is perfect and there is no transfer of heat, energy or matter at all. Slowly, this isolated system also starts losing energy after few hours. Next, we are taking closed system. Closed system can exchange only energy with the surroundings but not matter. For example, if water is in closed bottle, boundaries of the closed system act as a conductor of heat. That is, heat can be exchanged with the surroundings but matter remains inside only. If we heat calcium carbonate in a sealed tube, here also carbon dioxide formed cannot escape into the surroundings. But whatever heat is exchanged with the surrounding, that will change the temperature. So another example of a closed system is tea or coffee placed in a closed kettle. No doubt it will become cold, but its taste will not change. Becoming cold means exchange of energy, and not change in taste means no exchange of matter. So this diagram shows closed system in which energy is being exchanged but not the matter. For example, pressure, temperature, density, composition, viscosity, surface tension, color, refractive index, etc. are called macroscopic properties. Next, we are taking state of system. Now, state of system is very important. For thermodynamic changes, to measure the energy changes, we have to define the state of system. The system in which the values of macro properties which are mentioned above like pressure, temperature, density, composition, viscosity, surface tension, color, refractive index, they are definite, that they have fixed value. It is called, the system is said to be in definite state. Thus, the state of system is determined by its macro properties. Next, we are taking most important state functions. Now, the properties of the system which depend upon only on the initial and final states and do not depend upon its path are called state function. Free energy is an example of state function. Enthalpy is a state function. Internal energy is a state function. Mainly change in internal energy is a state function. Same way enthalpy change is a state function. Now, what are the state function? They depend upon initial and final state and not on the path. Let's understand this with the help of example. The energy required to reach from ground floor to first floor remains the same whether you go by stairs or you go by lift. If you go by stairs, your muscular energy will be used. And if you go by lift, then we will use mechanical energy, electrical energy, and electronics energy. That is, various types of energy will be used. Path functions are which depends upon path. Work done is a path function. Heat absorbed is a path function. How much work will be done? It will depend upon the path. For example, if you want to open the cold drink bottle without bottle opener, the work done will be very high. But if you do it with the help of bottle opener, work done will be less. So Q separately and work or path function, they depends upon the path or the way how work is done. So we have differentiated between state function and path function. Extensive properties. Those properties which depend upon amount of substance present in the system are called extensive properties. For example, mass, volume, they are extensive properties. Heat capacity, entropy, enthalpy, free energy, internal energy, all are examples of extensive properties. Now we are taking intensive properties. Those properties do not depend upon amount of substance present in the system. For example, temperature. Now, if you take temperature of small amount of water or large amount of water in a beaker, its temperature will remain the same. Same way, density of small portion or bigger portion remains the same. So, temperature, density, viscosity, melting point, boiling point, surface tension, refractive index, they are intensive properties. And also remember the ratio of two extensive properties generally becomes intensive properties. For example, the ratio of mass per unit volume is density, which is an intensive property. Thermodynamic process. The process by which a system gets changed from one state to another state is called thermodynamic process. Means system undergoes a change. For example, if ice is heated, it changes to liquid water. So here there is a change in state. So this process is called thermodynamic process because energy is involved in this change. And in most of the changes, energies are involved. And chemical change, definitely energy will be involved. In physical change, it may or may not be involved, or it may be small amount of energy is involved. Macro properties get changed in this process. Now, this is also very important. The change will be measured with the help of macro properties, and these can be of two types. First, we are taking isothermal process. Now, as the name suggests, iso means same, thermal means temperature. So, isothermal process is a process in which temperature of the system remains constant. And in this process, boundaries of system are mobile. So, in isothermal process, in simple way, we can say the temperature remains constant or there is no change in temperature or delta T is equal to 0. Now the energy released in this process is absorbed by the surroundings and the system takes the required energy back from the surroundings while the temperature remains constant. So how a system maintains the temperature constant? This is by exchanging energy with the surroundings. And when it maintains the isothermal condition, that is delta T is 0, so delta U also becomes 0. So delta U depends upon change in delta T. So if change in temperature is not taking place, so change in internal energy also will not take place. Delta H will also be 0. Enthalpy change also will be 0 if delta T is 0. Now we are going to take up maximum work done in expansion of n moles of ideal gas. First of all, in expansion, work will be done by the system and it will depend upon how many number of moles of gases are there. It will also depend upon initial volume, final volume, or initial pressure and final pressure. So W maximum is equal to minus 2.303 nRT. N is number of moles, R is 8.314 joules, T is temperature in Kelvin, log V2 over V1. V2 is final volume and V1 is initial volume. It can also be equated as equal to minus 2.303 nRT log P1 over P2. Why we have taken P1 over P2? Because according to Boyle's law, pressure and volume are inversely proportional. So V1 I have already described is initial volume of the gas. V2 is final volume of the gas. Similarly, P1 is initial pressure and P2 is final pressure. Adiabatic process. Now this is also very important along with the isothermal process. In adiabatic process, there is no exchange of heat between system and surrounding. It is possible in closed system in which heat is not exchanged with the surroundings. It may be isolated. It will also take place in isolated system in which no heat exchange with the surrounding. But in this process, temperature can change. That is, it may increase or it may decrease. But Q will remain 0. Q means heat absorbed or heat released will be 0. So that is the characteristic of adiabatic process. Isobaric process, as the name suggests, iso means same, baric means pressure. That is, in this process, pressure remains constant. And if pressure remains constant, it means the delta P is equal to 0. For example, vaporization of water. Now, when we carry out vaporization of water in open container, so external pressure is acting on it, and that external pressure remains constant for a particular instant of time, not for very long time, but for a particular instant it will be taken as atmospheric pressure. Heating of water up to its boiling point at the same atmospheric pressure is also an isobaric process. Next, we are taking isochoric process. So, from the name, iso means same, choric means volume. That is, this process takes place at constant volume. And if there is constant volume, it means there is no change in volume. That is, delta V is equal to 0. Cyclic process. The process in which a system proceeds via many intermediate steps and return to the initial state. Now, this is very important. If your initial and final state is same, then change in internal energy, that is delta U, will be equal to 0. Change in enthalpy, delta H, will also be equal to 0, and internal energy and enthalpy will be taken in detail. But you can remember that delta U is the energy change. Internal energy change is measured at constant volume. That is, when the process is carried out in closed container. Whereas enthalpy change is measured at constant pressure. That is, when the process is carried out in open container. So this difference in keep in mind, and remaining details we will be studying a little later stage.